Good morning. This lesson is for my honors integrated 1 class. This lesson is for section 24.4. Before I get started, I want to say I hope that everyone is doing okay out there. We've only got 2 more lessons. Today's and Thursdays. So let's just go ahead and jump right into it. This is a lesson that is really a lot about using congruent triangles, and that becomes a reoccurring theme in geometry. We're also going to use properties of isosceles triangles, and we're going to use the idea of when you have a 4-side shape that the 4 angles must add up to 360 degrees. So let's just go ahead and jump right in. Our goals are to determine when, and this symbol means parallelogram. So determine when parallelograms are rectangles, rhombus, and squares. I'm not going to go over the last one, but in order to have a square, it has to do both. Okay. Now, I think it's important for this lesson to help us hopefully understand it, that we are well versed in the properties of parallelograms. Parallelograms for this lesson do 3 things that'll help us accomplish determining if the parallelogram is in fact a rectangle or a rhombus. Okay, so a parallelogram has 2 pairs of opposite parallel sides, which means that we're going to get congruent opposite angles, congruent opposite sides, and we're going to get bisected diagonals. Diagonals bisect each other. Okay, so this is what parallelograms do. So if I have this, I get these 3 things automatically. All right. And somehow, some way, these ingredients will allow me to determine if I have a rectangle or rhombus. Now, what we're going to be doing is we're going to be looking at a parallelogram that has a unique characteristic to start off with. And hopefully we can use that little characteristic or clue to reason if we have a rectangle or a rhombus. So let's start off with the rectangles. Remember, rectangles have 4 right angles, okay? And in this first picture I have here, I have a parallelogram, and all we're starting with is 1 right angle. Okay, so let's make sure that we understand what we're starting with. We're starting with 1 right angle, and this unique characteristic of this parallelogram should be enough for us to reason that we have a rectangle. So let's look at our properties of parallelograms. Remember, opposite angles are equal, right? So that's a right angle. I can very quickly reason that must be a right angle, right? And we know that the 4 angles must add up to 360 degrees, right? So the 4 angles add to 360. Okay. Now we've got 2 of the angles taking up 180 of that, right? So that means that the remaining 2 angles have to add up to 180 degrees. Now remember, opposite angles are congruent, right? So that means that this angle is the same as that angle. And if the 2 angles are the same and they add up to 180 degrees, that forces both remaining angles to be right angles. So again, starting with a parallelogram that has 1 right angle, we can reason that the other 3 angles themselves must also be right angles. So again, I'm trying to get to a point that I can say this shape has 4 right angles. And if I can do that, then I've argued that the starting characteristic that I have is good enough to say that that parallelogram is unique enough to be a rectangle, right? Alrighty, so let's look at the second one. The second one, we have a parallelogram, and we're starting off with the characteristic of having equal diagonals. So the length from A to C is going to be the same as the length from D to B. Now, I do need to say something about triangles here, isosceles triangles in particular. Alright, so I just want to make sure that I have enough space here. Alright, so remember, if I have a triangle that's isosceles, I get two pairs of congruent angles, right? Alright, so I just want to keep that in the back of our minds here because I'm going to be using that here in a couple seconds. Alright, so let's go ahead and work our way through this. So remember, this idea of having equal diagonals is a characteristic that will lead us to having 4 right angles in this parallelogram. Now, remember the diagonals are equal to each other. So from here to here is the same as from here to here. And diagonals also bisect each other in parallelograms. So, if I know that, like, let's say this length from here to here is 10, then I know that the length from here to here must be 5 as well as that length, right? And if this is also 10 because these are the same, then that means that this is 5 and this is 5, right? So we can very quickly realize that we have 4 equal lengths right here. And if we look at this top triangle, actually, yeah. Well, let me backtrack a second. I can very quickly reason that this triangle on the top is going to be the same as this triangle on the bottom by side angle side. I can also do that for these triangles right here and here. These two triangles are going to be the same because of side angle side. Okay. Now, again, because I have triangles that are isosceles, right? This is a isosceles triangle. That means that this angle and this angle must be the same. So I'm going to put a little red dot here and here because these angles are the same. But these angles must also be the same as these angles, right? Because we know that these two triangles are identical, and if the shape as a whole is identical, then the parts in the same places themselves must also be identical. So if we also look at these triangles, we know that these guys again were congruent by side angle side. I know that this angle must be the same as this angle, and since this triangle is the same as that one, these angles must be the same. So again, these blue angles are the same because I have isosceles triangles, and they must be the same as that. Now remember, the 4 angles of a shape add to 360 degrees. And since each of the 4 angles of my shape are made up of 2 identical angles, a red angle and a blue angle, a red angle and a blue angle, a red angle and a blue, and a red and a blue, each of these measurements as a whole, this angle right here has to be the same as this angle right here, and it has to be the same as that angle right here, and that has to be the same as that angle right here. So my 4-sided shape has 4 equal angles. And if I have 4 equal angles in a 4-sided shape, and all 4 angles add up to 360, we must be able to conclude that those 4 angles must be right angles, right? So having equal diagonals is a feature that allows a parallelogram to go into being a rectangle. It gets to be a little bit more. Let's move on to our last idea, rhombus. Okay. And if I'm going a little fast, you can hit pause and rewind it. I'm not going through this with the 2-column proofs. I think I don't have the board space, and I think I get a little diluted. I'm trying to just discuss why these work. So hopefully this is making sense to you. And again, this is a wonderful section in the book because we're making arguments, and we have to use what we've learned before. This next one, these next special features of parallelograms, they all end up going back to one idea here. But let's talk about a rhombus here for a second. A rhombus has 4 equal sides. I don't know what letter that is. All right, so that means that all 4 sides are the same. And in this first problem, it's kind of hard to see, but I'm starting off with a parallelogram, and the special feature of this parallelogram that hopefully is good enough to take us to being a rhombus is that we have 2 sides that are the same that are next to each other. Right? I believe in the book it says 2 consecutive sides must be the same. Well, again, remember, rhombuses have 4 equal sides, right? But this shape is a parallelogram, which means if I have a parallelogram, I have equal or congruent opposite sides. So I know that this side must be the same as that side just because it's a parallelogram. But if this is the same as this, and this is the same as this, by the transitive property, we can say that all 3 sides are the same. And again, using this idea of congruent opposite sides, I know that this side must be the same as this side, right? And so I know that this side is the same as this, and this side is the same as that. And by the transitive property, this side must be the same as this. And we now have the criteria of 4 equal sides. So starting off with 2 sides that are the same, 2 consecutive sides that are the same in a parallelogram, that forces that shape to go beyond just being a parallelogram and becoming a rhombus. All right. So again, 2 congruent consecutive sides. I'm gonna argue to that. So for these last 2 problems, what I'm gonna do is I'm just gonna show that 2 sides next to each other on my parallelogram are the same, and if that's happening, I'm back to my first case. And if I can get back to my first case, then I can say, hey, I've already made that argument, and we can conclude that the parallelogram itself must be a rhombus. So here we go. The second unique criteria with a parallelogram, this is a parallelogram, and what this is doing is the diagonals are perpendicular. Diagonals aren't necessarily perpendicular. We can see that in the previous problem. So, but what makes this parallelogram unique is that the diagonals make a right angle. Now remember, diagonals bisect each other, right? And since they bisect each other, that means that this length is the same as that length. And this length must be the same as itself. It's a reflexive property. And I have a straight line here, so if I have 90 degrees there, I must have 90 degrees there. And so what that means is I have 2 triangles that are the same because of side angle side. And since I have 2 triangles that are the same by side angle side, I can conclude that this side must be the same as that side, right? And so now I'm back to my first problem where I have a parallelogram that has 2 sides, 2 consecutive sides that are equal, and I have 2 consecutive sides that are equal. Which what that means is this satisfies that criteria, which means that we have 4 equal sides, so this parallelogram must be a rhombus. Okay, so I hope that makes sense to you. My dog's going to start to bark. The mailman just dropped something off. Alright. The last problem, what we're starting with here, is I have a parallelogram. And what this is showing me is that this diagonal is cutting this angle in such a way that these angles are the same and these angles are the same. And so what this starting criteria is if I have a diagonal that bisects, if I have one diagonal that bisects opposite angles in a parallelogram, that's going to be a good enough criteria to get to a rhombus. This argument is actually pretty easy. Notice I have 2 triangles that have, actually these 2 triangles are the same. That's a pretty easy argument. But these 2 triangles have identical base angles. And if I have identical base angles, I can argue that that triangle must be isosceles. So that means that these must be the same. And if I have 2 equal sides, 2 equal consecutive sides in a parallelogram, I'm back to my first idea. And that parallelogram must be a rhombus. Okay? So, this lesson is determining, do you have a rhombus, do you have a rectangle, do you have a square? So we got one more lesson. Let's make sure we're finished strong. And again, I hope everyone's doing all right out there. And I will post the assignment here in a couple minutes. So have a good rest of the day, everybody.